Each system of equations below results in infinite solutions. Explain the geometrical situation for each case. So for the first one we have 3x minus 2y plus z is 1, 6x minus 4y plus 2z equals 2, and negative 9x plus 6y minus 3z is negative 3. If we multiply this second equation by a half, we get 3x minus 2y plus z is equal to 1, which is the same as the first equation. If we multiply this one by negative a third, we get 3x minus 2y plus z is equal to 1. So it's three planes listed, or three of the same plane listed. It's the same plane three times. So we get a plane of solutions. Let's look at the second one. 5x minus 2y plus z equals 7. 3x plus y minus z equals 4. This one is clearly not parallel to this first one. Just look at the normals. And then we've got 10x minus 4y plus 2z is 14. Well, if I multiply that one through by a half, I get 5x minus 2y plus z equals 7, which is the same as the first one. So we've got a plane which is listed twice, and then another plane cutting across there. And that one would result in a line of solutions where they cross. So it's worth looking at these on the calculator and seeing what happens when we do these on the calculator. So let's look at the first one. Remember, we've got to get the simultaneous equation solver, click it a second time, and then we've got space for three equations. And I've got 3x minus 2y plus z, and that is equal to 1. And then I've got 6x minus 4y plus 2z, that's equal to 2. And then finally I've got negative 9x plus 6y, take away 3z, and that one's equal to negative 3. And we're solving there for x, y, and z. And when we do that, you can see here that we have y equals y, z equals z, and the x defined in terms of y and z. Effectively, that's two parameters. It's giving us two parameters, lambda and mu, with the y and the z, and then defining x in terms of those parameters. And that tells us that we get a whole plane of solutions. We can move all over. Now, if we look at the second set, so let's put this second set in. We've got 5x minus 2y plus z is equal to 7. And I'm just going to pause the recording while I put the others in. You don't need to see that again. Okay, so I've got them in now, and let's look at what happens. Notice that we just get z equals z. That's defining one parameter, such as a lambda, and then x and y are defined in terms of that parameter. So with just one parameter varying, that's where we get a line of solutions rather than a plane of solutions. So you can tell the difference when you're solving on the ClassPad.